Okay, so here we have a graph of a function y equals fx. Now, between this graph and the x-axis, and between these two numbers, x equals a and x equals b, we have a bounded region. Now, let's say we want to approximate what is the area of this bounded region. Now, in the previous video, we saw the idea of using the areas of rectangles to approximate this, right? Okay, let's say I'm gonna use n rectangles to do this. And like we said before, we wanna each rectangle to have the same base. In other words, they have each rectangle, they should have the same width. Okay, and then if I can know the height of each rectangle, then I multiply the height by the width. I can have the area of one rectangle, and then I add the area of these n rectangles. The total area of those rectangles will be an approximation to the area of this bounded region, right? So this is the idea we learned before. So now I will show you what is the formula we use, what is a general formula we use to determine the width and the height. So first, the formula for determining the width is this. Why? Because consider that the distance between these 2 points, A and B, that distance is B minus A. Okay, since we're gonna have n rectangles, that means I'm gonna divide this interval from A to B into n subintervals. So we're gonna have n subintervals. Therefore, the length of each subinterval is given by b minus a divided by n. Okay, so the width of the rectangle is given by this formula. Now, let's take a look at the height of each rectangle. Well, after I divide this into n subintervals, I'm gonna have in total there will be n plus 1 points. The first point I called x0, which equals a, and the last point I called xn, which equals b. Before we decide how to determine the height, we need to figure out what is the coordinate of each point between A and B. Remember we said the length of each subinterval is equal to delta x. So this is delta x, and this is also delta x, like this is also delta x. So if the first point x0, the coordinate is a, then the next point is gonna be a plus delta x. And the point after x1 is a plus delta x and add by another delta x. So it's a plus 2 delta x. And x3 is x2 plus another delta x. So it is a plus 2 delta x plus delta x, which give us a plus 3 delta x. Now, can you see the pattern for for writing the coordinate? The pattern is the coordinate of the point between A and B. We can write it as A plus something times a delta x, and that something is equal to this number. So therefore, the coordinate of the point xk we can write as a plus k times delta x. Okay. All right. Okay. Once we figure this out, then we have 3 different choices for determining the height. The first 2 are using left endpoint method or right endpoint method. Okay, so if I use the left endpoint method, then the height of the rectangle is given by the function value of the left endpoint on this subinterval. So that will be so the rectangle gonna be like this. So the height is the function value f of a plus k minus 1 times delta x, because at this point, at x k minus 1, its coordinate is a plus k minus 1 delta x. Now, if I use the right endpoint method, then I'm gonna use the function value at the right endpoint of this subinterval to determine the height. In that case, the rectangle gonna be like this. And the height is the function value f of a plus k times delta x. Okay, we used these 2 methods in the previous examples, right? Now, actually, there is a third method. The third method is to use the middle point to determine the height of the rectangle. So we consider what is the middle point between these 2 points, xk minus 1 and xk. So now the middle point gonna be the sum of these 2 divided by 2. Right? For example, like what's the middle point between 1 and 3? That is 2, right? Because 2 and equals 1 plus 3 divided by 2. Okay. And since we know how to write the coordinate of each point of xk minus 1 and xk, so this average gonna be a plus k minus 1 delta x plus a plus k delta x over 2, which is a plus k delta x minus okay, let's see, we can do this way. So we have 2a over 2 plus k minus 1 delta x plus k delta x over 2. And 2a over 2, that's a. And for the second term, if we factor out delta x, we're gonna have k minus 1 plus k over 2 times delta x. Okay, so that's how we find the coordinate of this middle point, and the height of the rectangle using the middle point gonna be the function value at this number. So that's f of a plus k minus 1 plus k over 2 delta x. Okay, so if I use the middle point to construct the rectangle, it's gonna be like this. So the rectangle gonna be like this. Okay. All right. Now since we know the width of each rectangle and we know the formula of height of each rectangle, so we multiply them together, and this will give us the, and then we add them up. This will give us the approximation using each method. So using the right endpoints method, the approximation gonna be f of a plus k delta x. Now again, remember this term represent the height of the kth rectangle, and the delta x, this term represents the width. And because delta x is b minus a over n, so this equals f of a plus k times b minus a over n times b minus a over n. And if we use the left endpoints method, the result will be this. And the middle point method, the result is this. Okay. And then after we add up each term, the result will be something contains m. And next, to find the exact area of the bounded region, like what I did in the previous video, we take the limit of this term, we take the limit as n approaches infinity, then that will give us the exact area of this bounded region. Okay. So right now, these are the formulas of using each method.